10, 9, 8.
Launch auto sequence has started.
6, 5, 4, 3, 2, 1.
Go for launch.
Vehicle is supersonic.
Stage separation confirmed. Dragon, separation confirmed.
Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
Hello everyone, it's Tuesday, May 28th, and you're looking at a live view of our Falcon 9 rocket awaiting its 3:20 p.m. Pacific time launch from Slick 4 East at Vandenberg Space Force Base in California. Today's launch marks SpaceX's 56th mission of 2024 and the 340th overall Falcon 9 mission to date. My name is Zachary Lupin, and I'm an avionics reliability engineer here at SpaceX, and I'm joining you from our headquarters in Hawthorne, California. Welcome to our live launch coverage of the EarthCARE mission, a European Space Agency Earth Explorer mission developed as a joint project between ESA and the Japan Aerospace Exploration Agency, or JAXA. Now, the CARE in EarthCARE is an acronym that stands for Cloud, Aerosol, and Radiation Explorer. Once in space, EarthCARE will collect data to answer questions about Earth's radiation balance, which is a key factor in regulating Earth's climate. It will also measure vertical profiles of cloud particles and aerosols and their fall speed, or the speed at which the particles and aerosols fall through the air. This data will be used for climate research and will improve the accuracy of climate models and support weather predictions. We'll have more to share about today's payload later on in the webcast. Currently, both the vehicle and range are green, and we are on track for an on-time launch at 3:20 p.m. Pacific time. For now, let's meet the vehicle and learn a little bit more about the most flown U.S. launch vehicle ever, our Falcon 9 rocket. Falcon 9 is a two-stage rocket developed and manufactured by SpaceX, known for its safe, reliable, and cost-effective access to space. It is also the first and currently the only orbital-class rocket capable of reflight. Starting at the top of the vehicle is the Payload fairing, a protective shell that encases the payload being sent to space. That fairing will separate and jettison away from the vehicle, exposing the payload once Falcon 9 reaches space. Today's payload, currently encapsulated in those payload fairings, is ESA's EarthCARE.
Spacecraft is on internal power.
ESA's EarthCARE satellite. Equipped with 4 primary instruments, EarthCARE will make a range of measurements that together will shed new light on the role that clouds and aerosols play in regulating Earth's temperature. The mission's data will be used for climate research and will improve the accuracy of climate models as well as support higher fidelity numerical weather prediction. Continuing down the vehicle, we have the second stage. Now, the second stage is powered by a single Merlin vacuum engine, or MVAC, which is optimized to perform in the vacuum of space. After stage separation, the MVAC will ignite and carry the payload to its final orbit. The Falcon 9's first and second stages are connected via the black inner stage, which houses the MVAC engine and the system that decouples the two stages during stage separation. And below that is the Falcon 9 first stage, which is powered by 9 Merlin engines. These 9 Merlin engines provide the initial thrust to lift Falcon 9 off of the ground through the lower, thicker part of the atmosphere. And there are 8 engines arranged around one center engine, which are held in place by a structure called the octaweb, a shape designed to maximize efficiency. Now, each of these Merlin 1D engines delivers about 190,000 pounds of thrust at sea level, which gives Falcon 9 a combined 1.7 million pounds of thrust. After stage separation, Stage 1 will return to Earth for recovery and reuse on a future mission using a combination of the Merlin sea level engines and the 4 titanium grid fins located near the top of the booster, which will guide it during its re-entry and landing. The Falcon 9 first stage is also equipped with 4 landing legs that will deploy just before landing to allow for vertical touchdown on a drone ship or a landing pad. And today we'll be attempting to land this booster on Landing Zone 4 at Vandenberg Space Force Base in California. Now, weather and systems continue to look green for today's launch, and let's learn a bit more about today's EarthCARE payload on the pad.
We are facing a climate emergency. Understanding our planet is more critical than ever before. Our Earth is a complex system. To protect it, we need to fill in the missing piece of the climate puzzle. How do clouds and aerosols affect Earth's energy balance? While we know that they play extremely important roles in regulating our atmosphere's temperature, we don't know how their behavior will change as our climate warms. This is where EarthCARE comes in. ESA's Earth, Cloud, Aerosol, and Radiation Explorer will shed new light on how clouds and aerosols affect our climate. With its suite of 4 cutting-edge instruments, EarthCARE represents a groundbreaking advancement in satellite technology. It promises to deliver unprecedented data, unraveling the complexities of clouds and aerosols. With this, we can refine our atmospheric models and climate forecasts, giving us the tools to tackle the challenges of a changing climate with greater accuracy and precision.
Tonight's launch is a reminder that space is not only about exploring distant galaxies and planets. It is about understanding our beautiful but fragile Earth so we can protect it and improve life on our home planet. EarthCARE is a groundbreaking mission developed by the European Space Agency in collaboration with JAXA, the Japanese Space Agency. It is thanks to this collaboration that we have been able to build such a sophisticated satellite. I should like to personally thank all the teams involved who designed and built the satellite and got it where we are today. They have shown a major commitment of time, talent and tenacity. I appreciate your dedication and share your excitement tonight.
I'd like to personally thank all the teams involved who designed and built the satellite, and to get it what we're here today, EarthCARE comes at a time perfect for climate science and climate communities worldwide. Let us seize this opportunity to deepen and expand our knowledge and to chart a course towards a more sustainable future for all of us. Go EarthCARE!
As you just saw, there's some really exciting science set to happen on this mission. But first, we need to get it to space. Now, in order to get the rocket and payload into any orbit, the rocket has to not only go up really fast, but it also has to go sideways. And as the rocket ascends, we'll tilt the engines, and that'll turn the rocket horizontally into what's known as a gravity turn. To help demonstrate this concept, we'll use an analogy popularly attributed to Sir Isaac Newton, who was the first person to formulate a comprehensive theory of gravity in his 1687 Law of Universal Gravitation. Newton asked to imagine firing a cannon from a really high mountain. The cannonball will arc, and then gravity will pull it down to Earth. Now, as you increase the power of the cannon, that cannonball will arc and land farther and farther away. Eventually, if you could continue to increase the power, the cannonball will end up in freefall around the Earth. Essentially, gravity is pulling down on the cannonball, but because of its speed and the curvature of the Earth, it never hits the ground. And this arc that constantly misses the Earth is called an orbit. Modern rockets like the Falcon 9 operate on the same basic principles of gravity and orbital mechanics that Newton described, but with modern technology. And Falcon 9 provides enough power and horizontal velocity to place its payload in orbit above the Earth.
Tanks are pressing for strongback retract.
Good call out there. You'll be able to see this today by watching the orientation of the Falcon 9 after liftoff. The rocket will go straight up until about the T+10 second mark, at which point we'll begin a shift towards a horizontal orientation from gimbaling the engines. So be sure to look for that after liftoff. Coming up shortly, the transporter erector, or TE, will retract away from Falcon. The TE is the large truss structure you see there next to the rocket. First, we'll see the clamp arms open around the second stage, and then the TE will pull away from the rocket by roughly 77 degrees. Now, that first stage is connected to a launch mount at the base of the TE, but the TE is hinged and will retract away from the vehicle in preparation for launch. You may hear the TE referred to as the strongback from the launch team, and it does a lot of heavy lifting in the lead up to launch. It's designed to transport, raise, and support Falcon 9 at the launch pad. The TE is also equipped with umbilicals or flexible lines that are used to route the vehicle's fluids, power, and telemetry from the ground systems to the rocket and payload until Falcon 9 switches to internal power and clears the pad. And as you can see on your screen there, the strongback is retracting away from the vehicle. At this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of rocket-grade kerosene fuel and liquid oxygen. Both the first stage and second stage should finish propellant loading about a minute apart from each other, with the first stage finishing up at around the T-3 minute mark, and the second stage finishing at the T-2 minute mark.
Stage 1 LOX load is complete.
And there's that call out that Stage 1 LOX loading has completed. As you may have noticed, there are white clouds forming around the vehicle. Those clouds are comprised of the chilled gas above the LOX tank that is vented overboard to maintain pressure in the tank as needed. And when that vented oxygen mixes with the warmer California air, it condenses into clouds. At the T-minus 60-second mark, Falcon 9 will be in startup, and this means that the rocket's autonomous internal flight computers will have taken over the launch countdown, and then just inside of T-minus 2 seconds, we'll light the M1D engines for liftoff. The EarthCARE payload continues to be healthy, and the Falcon 9 team is tracking no issues on the rocket. Weather is still looking green, and the range is ready to support our T0 of 3:20 p.m. Pacific time. And with that, we're proceeding into the last couple minutes of terminal count.
Stage 2 LOX load is complete.
And there's that call out that Stage 2 LOX loading is complete. Falcon 9 is now fully loaded with 1 million pounds of propellant and oxidizer.
Ground gas closeouts.
Good call out there. In about 20 seconds from now, we should hear a call out that Falcon 9 is in startup. And as a reminder, this is a call out that the rocket's autonomous internal flight computers have taken over the launch countdown.
Falcon 9 is in startup.
And there's that call out that Falcon 9 is in startup. Lastly, we're waiting for the launch director, or LD, to give the final go for today's launch.
LD is go for launch.
And with that call out that the LD is go for launch, we are set to launch ESA's EarthCARE payload.
T-minus 30 seconds. T-minus 15. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Full power and liftoff. Go Falcon 9, go EarthCARE. Vehicle pitching downrange. Take down chamber pressure now.
At T plus 30 seconds and counting, Falcon 9 has successfully lifted off from Slick 4 East carrying the EarthCARE satellite. Now, after clearing the tower, we tilted or gimbaled the engines to initiate a roll maneuver, which you may notice in the Stage 1 camera view. This enables the vehicle's
Power and telemetry nominal.
This enables the vehicle's antennas to stay in the best position for communicating with the ground. In just a few moments from now, we'll be throttling down the engines in preparation for max Q, or maximum aerodynamic pressure.
Vehicle supersonic. Max Q.
And there's that call out for max Q. Now, as Falcon 9 accelerates through the thicker lower atmosphere, the air density decreases, and Falcon 9 passes max Q once the air density lowers faster than the increasing speed of the vehicle. So keep an eye on the Stage 1 telemetry on the bottom left-hand corner of your screen to watch for these speed changes through Ascent.
And back chill.
Good call out there. And as a reminder, the rocket typically needs to go 17,500 miles per hour horizontally in order to avoid being pulled back down to Earth and get into orbit. Now we've got 6 events coming up happening in rapid succession. This will start with main engine cutoff, or MECO, where we shut down all 9 M1D engines on the first stage. Followed by that will be stage separation, where the first and second stages separate. Third will be the Stage 1 flip, a maneuver to turn the first stage around. Then we'll have the second engine start, or SES-1, on the second stage. Fifth will be the first stage boost back burn, a controlled burn that reduces the forward velocity away from the launch pad. And lastly will be fairing separation, where the two fairing halves will jettison away from the second stage. And all of these events should happen in just a few moments from now.
Nico.
Stage separation confirmed.
MVAC ignition.
Stage 1 boost back burn.
Fairing separation confirmed.
And there you heard and maybe even saw those 6 events that happened back to back, which again were MECO, stage separation, stage 1 flip, second engine start 1, the first stage boost back burn, and fairing separation. We'll be attempting to retrieve those fairing halves, both flying for their first time today, once they fall back to Earth with our recovery vessel, Go Beyond. Coming up shortly, we should hear a call out for boost back shutdown on the Falcon 9 first stage.
Stage 1 boost back shutdown.
And there's that call out for stage 1 boost back shutdown. We're currently T+3 minutes and 34 seconds into the mission. Our next major mission milestone will be...
Both vehicles are following nominal trajectories.
Good call out there. Our next major mission milestone will be the first stage's entry burn, which will take place just past the T+6 minute mark. Now, to start the entry burn, we will relight 3 of the M1D engines on the Falcon 9 first stage, which is similar to pumping the brakes to slow down the vehicle as it passes back into the Earth's atmosphere. The entry burn helps reduce the heat generated from the friction of the atmosphere and reduces the aerodynamic forces acting on Falcon, which helps maintain controlled flight and prepare for the landing burn. Now, during the entry burn, Falcon 9 is decelerating by firing its Merlin engines, but it's still moving really fast, and this causes the vehicle to fly through Merlin's exhaust gases, or plume, which deposits a layer of soot on the vehicle surface. And that soot comes from the carbon-based fuel that Falcon 9 uses, and with each flight, the soot builds up a little more on the outside of the vehicle. Some amazing views of the MVAC engine on our Falcon 9 second stage as it takes the EarthCARE payload to orbit. Reusability is key to lowering the cost of spaceflight, which enables more investments in critical scientific research. Now, the Falcon 9 first stage that is supporting today's mission is performing this entry burn for its 7th time, coming up shortly. Now, the Merlins on the first stage are optimized for sea level, and these achieve 190,000 pounds of thrust each during ascent and descent. At liftoff, Falcon 9's first stage has thrust greater than 5 747 airplanes at full power, and the MVAC engine on the second stage, with a much wider nozzle, is optimized to 220,500 pounds of thrust in vacuum. Now, as a reminder, the first stage supporting today's mission is flying for its 7th time, having previously supported NASA Crew 7, CRS-29, PACE, Transporter 10, and 2 Starlink missions. It's also worth mentioning that this is the 56th Falcon 9 launch of 2024 and the 18th launch of Falcon 9 this year from Vandenberg Space Force Base in California. Coming up in just a few moments, we should hear the call out for the entry burn on the Falcon 9 first stage.
Stage 1 entry burn startup.
And there's that confirmation of entry burn startup. This burn will last about 20 seconds and will slow the vehicle down in preparation for the landing burn.
Stage 1 entry burn shutdown.
And there's confirmation of stage 1 entry burn shutdown. We're now waiting for Falcon 9 to land back at Landing Zone 4 at Vandenberg Space Force Base in California. And it just so happens that Landing Zone 4 is actually only about 400...
Both vehicles are on nominal trajectories.
Good call out.
Stage 1 FGS has saved.
Good call-outs there. It just so happens that Landing Zone 4 is actually only about 440 meters away from Slick 4 East at Vandenberg.
Stage 1 transonic.
Good call out there that stage 1 is transonic. We should hear a call out for landing burn startup on the Falcon 9 first stage in just a few moments.
Stage 1 landing burn. Stage 1 landing light deployed.
And there you have it. Falcon 9 has successfully...
Stage 1 landing confirmed.
Falcon 9 has successfully...
Stage 2 FGS is saved.
Stage 2 is in terminal guidance.
Good call-outs there. Falcon 9 has successfully landed at Landing Zone 4 at Vandenberg. This was the 7th launch and landing for this first stage. And this landing marks SpaceX's 314th recovery of an orbital-class rocket, including first stage landings for Falcon 9 and Falcon Heavy. Coming up next, we'll hear a call-out for SECO 1, or Second Engine Cutoff 1, on the Falcon 9 second stage, currently on your screen.
MVAC shutdown.
And there's that call out for MVAC shutdown on the second stage. We're now waiting for confirmation of nominal orbital insertion.
Nominal orbit insertion.
And there's that call out. Now with that call out, we're just one major milestone left in our mission, which is payload deployment, coming up in about a minute and a half from now. Now, Earth Explorer missions like this one are state-of-the-art science and research missions that deliver data to fill gaps in Earth system science and demonstrate new space technologies. EarthCARE is the largest and most complex Earth Explorer satellite to date. The satellite carries 4 state-of-the-art scientific instruments that work together to provide a holistic view of the interplay between clouds, aerosols, and radiation, a cloud profiling radar, an atmospheric LiDAR, a multispectral imager, and a broadband radiometer. Together, these instruments will allow scientists to better understand the processes governing the physics and interaction of clouds and aerosols and their impact on Earth's temperature. We're expecting payload deployment of the EarthCARE satellite in just under 40 seconds from now. As a reminder, this is the 56th Falcon 9 launch of 2024 and the 18th launch of Falcon 9 this year from Vandenberg Space Force Base in California.
EarthCARE separation confirmed.
An amazing view there on your screen. Successful deployment of the EarthCARE payload. And with that confirmation, we'll be bringing today's webcast to a close. Today's mission marks SpaceX's 351st overall mission to date and 56th mission of this year. We want to thank the European Space Agency and JAXA for entrusting us with today's mission, and all of you for joining us this afternoon. If you're interested in following the EarthCARE mission further, tune into youtube.com/ESA for more. And if you're interested in more launch coverage, be sure to check out spacex.com/launches for the most up-to-date information. Thanks for tuning in, and we'll see you again soon.